Hey, what's up, guys? This is Cheng here. So today, let's take a look at daily challenge problem number 870, advantage shuffle. So you're given like two arrays, A and B, of the same size, and the advantage of A with respect to B is the number of indices I, which that the the AI is greater than BI, and we need to return any permutation of A that maximizes its advantage with respect to B. So for example, right, we have A is 2, 7, 11, 15, and B is this one, and then the output is this. Because if we do a permutation of A and B, so this one basically at each of the index, the number of A is always greater than B, right? That's why the advantage of this one is 4, right? And then for the second example here, right, the advantage after this permutation is 3, okay? Because right, so and the constraints is like 10 to the power of 4, right? So for this problem, so how can we approach this problem, right? I mean, of course, we want to find like a number who is greater than B at each location, right? For example, at 1 here, all numbers in A, they're all greater than 1. But, obviously we want to use the smallest number that is greater than 1, which is 2, right? Because if we can find the smallest number from A, which is greater than the current numbers, of course we want to use that one, because then we can save the other numbers, which is greater than the current one, to match the remaining numbers in B. So this leads us to a greedy approach, which means that we'll sort. Basically, we'll sort A and B, right? And then we'll try to do the match from the smallest to the biggest. Obviously, for the first one, we have 2, 7, 11, and 15, right? So after sorting B, we have 1, 4, 10, and 11, right? This is A, and this is B. So obviously, at each of the locations, we can always match. We can always find like advantage, right? That's why the answer is 4. But for the second one, right? So after sorting A and B, we have, so the A is 8, 12, 24, and 32, right? And B is 11, 13, 25, and 32, right? So this is A, this is B. So if we compare the first numbers after sortings, A is smaller than B, right? Which means that we cannot find this one. Which also means that this number will not have any advantage in any numbers of B because we sorted, right? So we can remove this one. And then with A we have second number, the 12, right? So 12 is greater than 11, right? And the 12 is the smallest number in A, which is greater than 11. That's why we will use 11 to match. Oh, sorry, we will use 12 to match 11, right? And then the next one is 24, right? After matching 11, we're gonna discard this number, and then we have 24 match 13, right? So that's why we can match this one, and then we can also match this 32 with this 25. That's how we find the 3 numbers, right? Yeah, I think that's gonna be our basic greedy approach here. Basically we sort this A and B, and then we look through from the smallest to the biggest. If we cannot find a match between A and B, we move A forward, and then the first time we find a match, right? We find like match, which means that with A the A number is greater than B, then we know, okay, we're gonna use that number to match B. Since we want to return the permutation, right, to match the B, which means that when we sort B, we also want to maintain the original index, right? Because here the index is 3, right? Because we want to output the final permutation. Yep. So with that being said, let's try to code here. First we have sorted A, right? Sorted A here, and then we also need a sorted B, right? Sorted B. So for sort B, besides the number, the value itself, we also want to maintain the index. So for me, I just use this one. I just do a num. I just make a tuple here for I and number in enumerate B, right? In this way, we have both the number and the original index, right? And then we have length of A is equal to n, and I have the answer, right? So at the beginning, I put everything into a -1, right? Because because -1 means we haven't found a match, right? And yeah, so and okay, so I think that there's one more thing. So how about the unmatched numbers, right? So for example, we have 8, 12, 24, and 32. So if you guys still remember, we didn't find a match for 8, right? So that's why we're gonna remove this one, but we cannot discard it because since we need the permutation, which means that in 8 we need to find a place for this unmatched number, right? So, but where should we put it? Actually, it doesn't really matter. Anywhere, uh, anywhere in the answer, in the final answer, whose value is -1, we can just put this any unmatched number to it, because the unmatched number, it means that we will never find a match for that number. So it doesn't really matter which one we put, as long as it's a -1 position, right? We can put it anywhere. That's why I'm going to also define like an unmatched numbers list here, and then to do the match, right? I just use 2 pointers, right? So I and j equal to 0, where the I pointing to the current sorted A array, and b and j pointing to the current sorted B array, right? So while I is smaller than n and j is smaller than n, right? So if sorted A dot I is greater, right, greater than the sorted B j, right, dot 0. So remember, in sorted B we store a tuple. That's why I use 0. If we find a match, right, and we simply use the index in the sorted B to update the final answer array, right? So we have sorted B here, and then we have j, right? So the j gonna be 1. That's the index, right? It's gonna be the sorted AI, right? And then after that, we move both cursors forward, right? Because we find a match, we can continue find the next match. Else means that the current A is smaller, is not greater than the current B, which means that we need to move the current A forward to find the next bigger number, right? But before doing that, we need to add the current number to the not matched numbers, so that we can fill in the remaining -1 slots, right? Okay, and then we increase the I by 1, right? And after this one, right, we do another like range for loop here to look for any numbers that we haven't matched before, right? As long as this one is equal to -1, right? That means that we need to fill in the we need to put fill in the numbers, right, from the not matched numbers. It doesn't really matter which sequence. I can simply fill in from the first one to the last one. Basically, the matched numbers dot pop, right? As every time when I see a -1, it means that we'll have like unmatched numbers. I simply pop the first one and assign this one to the answer, right? And then in the end, I just return the answer. Yeah. So if I run the code, accept it, right? Right. So passed, right? So, I mean, the time complexity for this one, obviously, we have sorted. It's going to be unlog n, right? Because here it's like basically as O of n, right? And then here is also O of n. So for this for loop here, actually maybe we can do a little bit of improvement. Maybe we can check if the not matched number is not empty. We do this for loop, right? Otherwise, we simply we know, okay, so we find the match for all the index already. But yeah, I think this one also, this for loop should, I mean, it works. Yeah, so let's see what else. Yeah, I think that's it, right? I mean, this one, I mean, we just need to to figure out, you know, we simply need to find the smallest number that can satisfy the current index from B, right? That's why we need to sort. We need to sort both A and B, while also maintaining the original index for the B. And then we just use the two-pointer techniques. In my case, right? I mean, we try to find the first number, basically the smallest number that can have the advantage of the current number B, right? And then we just use that number to update the final answers. If the current A cannot have any advantage of the B, we simply put it to the not matched numbers so that we can fill in the unmatched slots with this list later on. Yep, I think that's it for this problem. And yeah, thank you for watching this video, guys, and stay tuned. See you guys soon. Bye bye.